Hello, everyone. Welcome back to Hydra Book Reading Club, episode 5. And in this video, I'm going to talk about modulation, how to use modulate. Well, not so much about how to use modulate, actually. It's about how does it work. And I spent some time, like the text and code in the Hydra book that I wrote some time ago, how modulation works. But I'm not sure if that's clear enough. So I'm gonna like try to demonstrate it and without using Hydra. So this is maybe a rare episode that I'm not gonna code Hydra to explain Hydra. But let's see how it goes. Before jumping into the content, I want to just give a shout out to Glitch. Thank you for hosting the projects. And they're closing. Basically, they're shutting down the hosting service. I'm not sure if what it really means because Glitch is about hosting service, and it's been like free. I mean, there are also paid tiers, but mostly free. And a lot of Hydra related projects are hosted on Glitch. So if you are using glitch.com to host your project, basically including this Hydra book, because as you can see, it's hydrabook.glitch.me, which is the project hosted on glitch.com, glitch.me. So I have to migrate this to somewhere else. If you go to the forum, support.glitch.com, you can find a lot of resource how to migrate projects, download projects. Here is the community forum. You can find all this resource. It's like blowing up because everyone's like freaking out. But don't freak out. Your project is still there. You can just download them, copy it to GitHub pages or on your server and so on, and it's gonna be okay. I'll do the same with my Hydra book. And the Hydra editor itself is hosted, the code base is on GitHub, and the instance is running on Olivia and the community server, so it's going to be all fine, not going to be affected. But maybe some of the projects, spin-off projects, or some add-ons, plugins may be affected. So if you find something is like the link is broken and so on, just be generous, like this happens, and embrace the weirdness of web. So today, so going to the content, I'm going to talk about modulation. And I made some videos about this, I wrote about this before, but it's the kind of a tricky topic. It's something that's like exciting for everyone. I'm always excited about modulation, basically dot modulate function, right? And it's always like making some interesting things, but also it's hard to grasp what it is about. I just put OSC and modulate it with noise, and it makes this like wavy OSC that's shown here. But what does it do? And this is something I want to demonstrate today. And for this, I'm going to use P5JS. I know it's a also like a funny tool, I think, P5JS, but I think it's kind of if you don't know P5JS, you can just follow along. I'm not going to do like crazy things about this. You can like guess what is happening if you are like into some kind of coding, like open frameworks or processing, or I don't know, or maybe you just want to skip this episode. But also, like, I'm not going to write shader because basically that's not the point. You can do something very similar to Hydra using P5JS and shader, but that's not the point today. I'm going to like do something like very static and very slow, low resolution, but just to demonstrate what is happening under the hood. And basically this is the part in Hydra book that I'm going to demonstrate today. This is kind of like a pseudocode, so it's not like something that is for, how to say, you cannot just copy and paste to, I don't know, some kind of platform and it works, or framework and it works, but it's just to demonstrate what it is. And something that I'm going to do today is to get this idea, implement it in P5JS, and demonstrate what modulation is. And I hope this makes a bit your understanding further. I know like modulation is like, I know that you know the idea of modulation, but you will probably have more precise idea what it does. So, as I said, I'm going to this P5JS editor, and what I'm going to do today is everything is going to be static, because running this in real time is really not my point, just to show you how things work. So that's why I'm going to put no loop, basically so that it's not going to render again and again and again, because it's not a very efficient way of rendering the way I'm going to do it, because basically I'll just calculate every single pixel and simulate what's happening inside shader. The background doesn't really matter. So what I'm going to do is I'll just keep 400 by 400 canvas. So that's the width and height, and basically just going to iterate through. I'm kind of old school person, so first for loop is going vertically, height. Doesn't matter if it's scanning through height or width first, but basically just nested for loop, width and height. So basically what this J and I is doing is like or you can say X and Y. Maybe it's nicer because I wrote such in the pseudocode in Hydra book. So it's something like this. So basically we have X and Y just like scanning through the matrix or the pixels of the canvas. And for each X, Y pair, I'll calculate the color. And before like going to like modulation, now it's already like doing something like completely different from Hydra. Let's do something what we're very familiar with, that is OSC. Well, I'm familiar with OSC. So what I'm gonna do is let, I don't know, intensity maybe. It's just, I'm very verbose today. And you can do math.sine, or it's the same with just with sine, but I'm kind of like, I like to do math.sine somehow, because of portability. And, okay, I'll follow the P5JS rules here. It's gonna be the same, but sine, so OSC is going changing through X direction, so it's going to be X, but I think this is too much happening, so I'll just divide it by 50, kind of inspired by sine. Is it 50 or 60? Whatever. But it doesn't have anything to do with the number 50. Now, the sine function returns from -1 to 1. And you can do math to map it, because in Hydra we always work with 0 to 1. Like 0 is the black and 1 is white or red or green. In P5JS we work from 0 to 255, so we have to map it, and I'll just do map function. So sine goes from -1 to 1. I want to remap to 0 to 255. Semicolon or not, well, it doesn't matter. And there is this function called set. You basically have X and Y, the index where you want to set the color, and specify the color, which is the intensity in this case. The details are not so important here, and have to do update pixels to reflect all these changes. And if you hit it, then you see this familiar OSC pattern now in P5JS. And if you want to move it, you can add time element, time factor to it, but I'm not going to do it today. I could do it. Okay, I'm kind of excited about this, so I'm going to just do it to demonstrate. What I'm going to do is let time is millisecond, because millisecond I have to divide by 1000, or times 0.001, and I guess I just have to add this to here, something like this. Yeah, as you can see, like why I'm not doing like a live, like dynamic or moving pattern today is that this is very slow. I mean, it's not just a recording, but it is running very slow, because it's kind of, calculation wise, it's very intensive, very expensive calculation we're doing this, because for every frame we have to go through 0 to 400 X direction, and then repeat that 400 times. So 400 times 400 calculation for like setting the pixels, that has to happen 60 times per frame. Well, no, per second. Well, 60 frames per second. So it's basically a lot of computation. And why does Hydra work smoothly is because we're using shader, which is, so in P5.js, what I'm doing here is happening on CPU, and on Hydra, it's happening on GPU. You can do the same thing in P5.js as well. That's what I was saying about shader, to do GPU calculation, to do something just like Hydra. That's also possible. But again, this is kind of like, well, this is like unexpected outcome of this. We haven't been to the modulation yet, but this is a bit of like context. Like, and basically, because of all these things, I'm not gonna loop this. I'm not gonna loop this every frame because it will be very choppy and it doesn't look really nice. And still, we're like working with like 400 by 400. Is it actually 400 by 400 or is it 800 by 800? I don't know. This whole retina screen, whatever, so on. Okay, let's go back to the topic. So now I got sine. Maybe I'll say sine intensity, or I love OSC, so let's say OSC intensity. I took out the time factor, so it's going to be static, just like this. Maybe I'll increase the number of the sine periods, so that I moved from 50 to 20. So with smaller number, it will be more dense, denser. So that's how it happens, what it does now. And so this is OSC intensity. And just to demonstrate, I think it's nice to have noise intensity. And I can't, so there's no like easy way to recreate exactly like the noise function in Hydra, because there are different ways to implement noise, and the way they implement noise in P5.js is different from how Hydra's noise is implemented. And I'm gonna just cheat so that we assume that it's kind of the same thing. So visually it's not gonna be the same, but we'll just like assume that this is something very similar, because the pattern of the noise itself doesn't really matter. It can be Voronoi or it can be anything. So noise function basically in P5.js is how it works is you have to input x and y, and it will return number from 0 to 1. Sine was -1 to 1, noise is 0 to 1, and in Hydra noise outputs -1 to 1, so it's quite different, but it's okay. I'll just like multiply this by 255 and use this noise intensity as input to the color. This will not look nice because I divided x by 20. In the case of OSC intensity, I have to do the same thing, just like this, to make it a little bit more like cloudy, not repeating like random pattern. Well, so that didn't look random. That was a problem with this original one, that looks like just like repeating. So you have to, I don't know, maybe just try a little bit different number, divide by 10, or maybe even bigger, divided by 30. Yeah, it looks a bit more granular compared to Hydra's noise. It is because the implementation is different, but and I think there are different ways to tune the granularity of noise in P5.js, but I'm not going to go too much into detail because that's not really the point today. So basically, and also I can write the code so that the OSC and noise will be presented side by side and so on, but I think it's a little bit too much like overkill, like more like details about P5.js. So I'll just like assume that if I just copy and paste OSC intensity in here, it will show OSC. If I put this one in here, I get noise. And what I'm going to do is basically the same thing. I want modulate intensity or modulated intensity. value. Somehow I want to calculate this and use that to set x and y. Does it make sense? I hope it makes sense to you. To do this, basically what happens here is I'm going to do the very similar thing to OSC intensity. I'm just going to copy and paste and just pretending that if we modulate and if you modulate OSC with noise, but then if you put the second parameter at 0, then it's going to be like this, right? Well, I know I'm cheating, but if it's comma 0.1, then it starts to modulate, but if it's comma 0, then there's no modulate. So actually this is kind of like already modulated with 0. And from here, I want to modulate it a little bit with the noise. And basically what it does is we need both these formulas for OSC intensity and noise intensity. And well, for modulating, okay, let's look at this one. Well, it's a little bit different because I prepared pixel A, which is let's say the OSC intensity, and pixel B, which is noise intensity, and I want a new one, which is the modulated intensity. And the way, so there is this cryptic thing happening here, which is basically just about referencing the OSC intensity using the value of noise intensity. Let's just demonstrate it. I think it's better. So in this case, we're just using x as a parameter. It's a function of x, and I need to modulate this. What is modulating is not about changing a sine function, changing noise function. It's about just changing this x here, and I'll just shift it with noise intensity. Maybe it's too much, but let's see what happens. There you go. It's actually quite a good value. Maybe it's a bit too much modulation, but you get this idea that this does look exactly like modulation, right? It's not the pattern that we've seen in Hydra, but it does it has this resemblance to what we've been doing with OSC and modulating with noise, right? And maybe I'll just make this effect a little bit less by dividing by 5, and maybe it's a little bit too much. But you get this idea that, yeah, you see that this is something very familiar. That is basically what we would write: OSC, modulate, noise, out. So this is what I'm trying to recreate here. We have this OSC intensity, noise intensity, and modulated intensity. That is kind of what is in the out part. OSC intensity is obviously this one, noise intensity is obviously this one, and the way they are combined in Hydra is just use modulate, clean. If you want to do it in P5.js, then you have to take this noise intensity and bring it back to OSC intensity's X part. We're not changing sine to anything, we're not changing the mapping parameter, we're not changing anything but X, and that's pretty much it. If you have Y, then that will be also, well, in the case of OSC, it's not using Y, but if you have Y parameter inside this function, then you also need to modulate this with noise intensity, or what is modulating, whatever. It's very simple pattern. I've been in very simple example, but the idea here is that I want to demonstrate what is happening under the hood. It's no magic. It's just very simple math. Basically, just if you compare this side by side, and now actually in this version I'm not using this at all. It runs without it, but I'll just bring it back in just for a demonstration, and you can see that what is different for OSC intensity and modulated intensity is just about X that is shifted a little bit by noise intensity. And just with this very tiny addition, it makes this very, well, intricate pattern, which is very interesting. Like, it's very, to me, when I discovered this, I was really surprised, like how simple it is, what modulation is. But understanding this really helps, so that you're not like just putting whatever random function, but you can start like really craft images if you know this. Also, like a little bit of detail is that in the case of this noise intensity, we only have like RGB, like same value. But if RGB are different, for example, in the case of gradient or OSC with like shifted sync value, then what happens here is when you modulate, it's taking red channel to shift X value, green channel to shift Y value. It's not very straightforward, like how to do this, but maybe this is better to demonstrate coming back to Hydra editor. And so what we were just doing is basically OSC. Let's stop it and modulate it with noise, and I'll stop this one as well. So basically I was like recreating this, right? And again, the noise function behaves different in P5.js and Hydra, so the patterns are not identical, but you get the idea that it's something very similar to each other. And here I'm using just X, because OSC is only dependent on this X value. It doesn't matter which part, like if it's Y at the top or Y at the bottom, it's the same, like this. So what I want to say is, for example, if you take color 100 of noise, so basically just taking red channel, it doesn't change the result. But if you just take green channel, it goes back to OSC. This is kind of the weird or funny thing, that this fact itself is not really helpful for your creating mesmerizing visuals, but it's just like a little detail that I want to demonstrate here, that here, if I make it really verbose, noise intensity, red, green, in this case, because noise is like grayscale, like red, that means red, green, blue, those all the channels are the same color. So that's why they're all calculated in the same way, so that they are the same color. And what is happening here is basically we're using noise intensity red to calculate, to shift X. And if there is Y channel in OSC intensity, then it will be shifted by noise intensity green. And if we swap them, for example, noise, so what if noise is modulated by OSC? What kind of pattern is it? I'm just curious. Yeah, it's not particularly interesting pattern, but let's just work on this a bit. And what I can do here is 1.6, which is more like a colorful version of OSC. Like that itself is like this. And if you do something like this, or if you just do like gradient, well, it's not really, yeah, it's not really obvious because of, maybe I can do something like this. Yeah, not really. Anyways, so if you do this, now it's what's actually happening under the hood is now red and green channel in this function are different, right? That's why it's not like grayscale color anymore, but it has red, green, blue. You can see this spectrum. Well, it's not the color spectrum, but spectrum of colors or hues. in the texture. So now it's starting to modulate things. So what's happening here is, I'm gonna just demonstrate it here, that, so we're like switching the relationship now. Noise intensity, so now we're saying like noise here, and OSC is here, and OSC intensity, I'll just like, just for demonstration, I'll just make it like OSC intensity red, green, and what happens here is that OSC intensity red and green will be a little bit shifted from each other, something like this, and modulated intensity is now based on, instead of sine function, now it's based on the noise function, so it's coming from this one, and OSC intensity red is affecting this one. The X channel, the X value is affected by red color. The Y channel is affected by the green channel. And if I run this, yeah, it's a little bit too exaggerated now because I didn't divide it by, well, I don't know, divide by 2 or something. But you see like this kind of mountain kind of pattern that is also present in this one. So it's not really like a best illustration of how these separate channels affect the color. Well, I actually kind of like this. It's very abstract, and it's so also like cloudy. It's very interesting. It's very different from how Hydra outputs because of the noise pattern, I think. So this was like a kind of demonstration of how modulation works and what I wanted to present in this like little snippet of code. And I did say it's just like, you know, processing open frameworks. But I think it needed a little bit more elaboration. So that's why I spent this video to recreate this, and I'll put this, I'll save this sketch and put it into the link down below, so you can try it out, you can change things, and, you know, of course, like, feel free to like use it. And if you happen to make interesting P5JS patterns, that's also great. It's like a nice side effect. And it's also like nice to like switch. I don't really say this in the videos because it's, the videos are about Hydra, but if you happen to use different tools like P5JS, or it can be something very different, I don't know, it can be also like, you know, drawing something with CSS, or using HTML canvas, which, I mean, P5JS is based on HTML canvas, but if you happen to make use these tools, it might stimulate your brain in different ways that maybe you want to bring some of these things back into Hydra. Just think about, how can I do this in Hydra? That's also an interesting experiment to do. Like, it's easy to draw, well, you can draw a circle in Hydra, but let's say like the polygons in P5JS, like, how can I recreate this in Hydra? Is it possible or not? Is it, or like maybe you want just to output an image and load it in Hydra, that's also fine. You can also combine P5JS with Hydra. That's also, if you go to these add-ons, you can find some examples here. Yeah, it's loading a little bit slow, but is it here? It should be somewhere, but you can find P5JS example here, and yeah, it's here, P5JS, and you can just try out examples, and maybe you just want to like merge them. Then it's, you know, really like sky's the limit. Like, you can go crazy with your creativity, and, you know, I hope that it's not just like these videos are just about Hydra, but you can apply this to different things, and, you know, also you can use these patterns to put it into your portfolio if you know how to embed Hydra into HTML, which is totally possible. I mean, that's how Hydra editor works. So yeah, please let me know if you make something interesting, or if you have wishes, just please comment down below. Thanks for everyone who's been commenting and liking the video. And I will see you in the next video. Bye.